Question 7 is about finding the midpoint of a line. So the point A has the coordinates 3, 8. Point B has the coordinates 7, 5. M is the midpoint of the line segment AB. So M isn't on there. I'm going to put it there. That's M. It's the midpoint of AB. Find the coordinates of M. So coordinates, remember, are written in the form of an x value, comma, y value, where that x value is going to be that value and the y value is going to be there. Now, in order to get a clear picture of what's going on here, I'm going to do exactly the same as I did there, but I'm going to do it with the points that already exist. Let me zoom. So I'm going to take this point, point A, and I can see that on the x-axis, point A is at 3, and point B on the x-axis is 7. Now, if I look at the y values I've already got, I can see that point A crosses the y-axis at 8. And I can see that point B crosses the y-axis at 5. So what I need to do is find the middle number between 3 and 7 and the middle number between 8 and 5. And just like in many other areas of maths, in order to find the midpoint of two numbers, you add them together and then divide by 2. So the first thing I'm going to find is my x coordinates. So in order to do that, I'm going to do 3 plus 7 divided by 2. And 3 plus 7 is 10 over 2, which is 5. So my x coordinate is equal to 5. Then I'm going to find my y coordinate. And the values I have for y are 8 and 5, and I need to find what's in the middle. So I'm going to do 8 plus 5 divide by 2, and that equals 8 plus 5, which is 13 over 2, and that equals 6.5. 6.5 is also correct. So what I found is a value for x and a value for y. So my coordinate is actually 5, comma 6.5. And this is only a 2-mark question because really you've just had to add two numbers and then half the answer. So it's only a 2-mark question. You get 2 marks if you have it correct. If you've only got one of the values correct, so if you've got 5 comma something or something comma 6.5, then that's when you get just 1 mark. Question 8 are your questions on index laws, and there's absolutely no excuse for getting these wrong now because they follow the same rules each time. We've got to simplify p to the power of 3 times p to the power of 5. Our number is the same, or our letter, which is p, and when you're multiplying you just add the indices, so it's p to the power of 8. For this one, we're dividing, so the answer is going to be h to the power of 7 take 2, which is 5. And for this, it's going to be x to the power of 2 bracket 3. Brackets mean times, so it's going to be x to the power of 2 times 3, which is 6. That's a 3-mark question. They're worth 1 mark each. Question 9 is a question involving not so much distance speed time. It's a little more straightforward than that. However, it does involve conversions between speeds in kilometres and miles per hour. So Mr. Smith drives 24 miles to work. On Monday, his journey to work takes 30 minutes. On Tuesday, his average speed is 56 kilometres. Did Mr. Smith drive more quickly to work on Monday or on Tuesday? You must show all of your work in. So let's have a think first of what the question's asking. It's asking us to compare Monday and Tuesday, and is asking us to compare the speed or how long it took him to get to work on those days. So both days he's driving 24 miles. We know that. It says it there. On Monday, and I'll keep Mondays down here, and I'll split this, and I'll have Tuesday there. So on Monday, his journey to work takes 30 minutes. So I'm going to say that 30 minutes equals that 24 miles. On Tuesday, the average speed of his journey to work is 56 kilometers per hour. Now, I'm not going to write it as 56 kilometers per hour. I'm going to say that there's 56 kilometers, and that took him 1 hour. So I can see straight away here that I've ended up with two distances and 2 units of time, none of which are consistent. That's 30 minutes, that's an hour. In order to compare them, I need to make the units of time standard first. Now, what's quite easy is going from 30 minutes up to 1 hour, because all I need to do there is double the amount of time. If I'm doubling the amount of time, I'm going to double the amount of distance that I could have been covered. So 1 hour would be 48 miles. So now my time unit is the same. By doing that, I've gained myself a method mark. So there's an M1 just by getting to 1 hour for both. Now I'm posed with a second problem, and that's the fact that this is 56 kilometers in an hour, and that's 48 miles in 1 hour. So I need to find a way of getting them both as either kilometers or as miles. Now, they don't give you the information for that. You're expected to realise that the conversion is 5 miles is equal to 8 kilometers. So that's the conversion key there. 5 miles is 8 kilometers. So you can then choose which one you wish to convert. I'm going to go ahead and convert from kilometers per hour into miles per hour. And because there are 8 kilometers in 5 miles, what I'm going to do is take that 56 kilometers, I'm going to divide it by 8, because that's what the kilometers measure is. So I'm going to divide it by 8, and that's going to equal 7. Then I'm going to multiply it by the 5 miles, because I want to get it back up to miles, and that's going to give me 35 miles. So what I've managed to do now is get my distances in a standard unit as well, and that means I can get my second method mark for getting the units standardised. I could of course have changed 48 miles to kilometres, and in order to do that I would just do the opposite here. To go from kilometres to miles, I divided by 8 times by 5. To go from miles to kilometres, I'd need to divide by the 5 and then times by the 8. And that's all to do with unitary method. So now I've got my 48 miles and my 35 miles. I've got the two numbers and their speeds. I'm going to write them as a speed. 48 miles per hour and 35 miles per hour. By stating both of the speeds, I get an answer mark for my numeric answer. The fourth and final mark is going to be my communication mark, because the question has actually asked me a very direct question, and that is, did Mr. Smith drive more quickly to work on Monday or Tuesday? So I've shown all my work in. All that's left for me to say is Mr. Smith, And I'm going to just literally copy how they phrased it in the question in case my writing skills aren't too good. So Mr. Smith drove more quickly to work on Monday. And I'm going to write the 48 miles per hour compared to 35 miles per hour on Tuesday. Now that amount of detail isn't necessary for you to get that C1 mark, but you do need to make it clear that you are selecting Monday based on your calculations. Question 10 is sequences and nth term. So here are the first 5 terms of an arithmetic sequence. Write down an expression in terms of n for the nth term of this sequence. Common mistake lots of people make on this question, let me zoom in. Common mistake lots of people make is they see all these n's and they know that they want to write an expression and they'll start by saying, oh well, n equals. And then they'll notice the fact that the numbers are going up in 4 and they'll say, oh, n equals 4. That is not what you need to do. First of all, it's asking for an expression. There is no equal sign involved. If they wanted an equal sign, they would have asked for an equation. So they want an expression. In terms of n, that means n is in the middle of it. It's based around n, and it's called the nth term. So what I do need to do is find 2 things. The first is the common difference. And then I need to find my plus or minus number. Now the common difference, you can see the sequence goes up by 4 each time. So that means that my common difference is 4n. And 4n is how we represent the 4 times table. So in order to find the adjuster, and that's whether you need to plus or minus any numbers to get the sequence, in order to find that, you need to consider your 4 times table. I always like to write whatever the times table I'm interested in is above the number. 4, 8, 12, 16, 20. And then from there I ask myself, how do I go from the 4 times table to the number of my sequence? So how do I go from that 4 to 6? Well, I add 2. Does that work for the next one? 8 to 10? Yes. 12 to 14? Yes. So it works for all of them. Therefore, the second part is add 2. Now this is a 2-mark question, and you get 1 of the marks for having the 4n identified with anything here. And obviously if you've got both parts right, that's another B mark, and there are your 2 marks. Part B says the nth term of a different sequence is 2n squared minus 4. Find the third term of that sequence. Now the whole point in the nth term is because the n is the position in which the number lies. So if we're looking for the third term, we're looking for the third term. And that's why it's called the nth term. So we're looking for the third number in that sequence. So n is equal to 3. My expression is 2n squared minus 4. I need to substitute that 3 into that expression. So it's going to be 2 times by 3 squared, and then we're going to take away the 4. Now this is an indices, so we do this first. 3 squared is 9. So then I've got 2 times 9, which is 18. Then I've got my take away 4, which is going to give me 14. There are more logical ways of setting this out, but whilst I'm talking through it, this is how I'm going to lay it out. And it's given me that 14 is the third term of that sequence. with regards to how marks are allocated for that question, you get a method mark for showing that you understand you need to substitute the 3 in instead of n, and then you get the final mark for having the answer of 14.